Alright, so like I said, what I want to speak about at the beginning today is the inverse sine function. We also call it the arcsine function, A-R-C-S-I-N-E, arcsine function. And so they both of them are notations for the inverse of the sine function. So you may ask, what are you talking about? Inverse of the sine function? Well, it doesn't have an inverse, right? I mean, if you consider the sine function on its entire domain, what's the graph of the sine function? Well, it's a wave, right? It's your engineer's favorite function, right? Periodic function. You guys talk about signals, right? Whoever is electrical engineers, right? Signals are functions, right? If you are looking at periodic phenomenon, of which you do a lot, then your favorite functions are sine and cosine, right? So the sine function is a function whose domain is from negative infinity to infinity, and we know that the graph of that the function sine is periodic with period 2 pi, and therefore it's not one-to-one, right? It's not one-to-one. Even if I restrict the function between 0 and 2 pi, it's not a one-to-one function, right? You agree? Why is it not one-to-one? Because it doesn't satisfy the horizontal line test. If you make a horizontal line at the height half, it intersects the graph at infinitely many points, right? So it's not a one-to-one function. Well, so what's the range of the sine function? The range of the sine function is from -1 to +1. Now, what I'm going to do, well, it's not the sine function on its largest domain is not a one-to-one function. So what I'm going to do is I'm going to pick a convenient interval where sine is 1-to-1, and we don't lose any of the range points. Okay, so I want to take an interval where sine is 1-to-1, and it doesn't lose any of the range points, meaning that the range of the sine function with the restricted domain will still be -1-to-1. Which one can I pick? Well, I'm going to pick from -π/2 to +π/2. So I am picking the interval from -π/2 to +π/2. Okay, from -π/2 to +π/2, and on that interval, the sine function has the graph which I highlighted with red, from -π/2 to +π/2. And is that one-to-one? It is one-to-one. In fact, it is increasing, and it takes on every single range value still, right? It doesn't miss out on any of the range values. So when I restrict the sine function on the small domain from -π/2 to +π/2, I still get all the range values. Okay? And we are going to take, so because it's one-to-one, it has an inverse, right? It's not singular, right? It has a special half, right? So it is. We are going to call the inverse of this red function to be the inverse sine function. Is everybody clear? Well, what's the graph of that? What's the graph of that inverse sine function? So in order to sort of make my graph more clear, what I did is I changed my scale, and I drew the graph of sine function. I drew the graph of sine function one more time, but in green, between -π/2 to +π/2. Between -π/2 to +π/2, I drew the graph of sine again. Is everybody clear? And why did I do that? Because I wanted to make sure you understand how I'm getting the graph of the inverse sine function. So everybody agrees that that's the graph, the green curve, that's the graph of sine between -π/2 and +π/2. There is no difference between this one and the red one, except that I changed the scale. Okay. Now, let's think about this. So on the graph of the sine function, what are the coordinates of this point? What's the coordinate of that point? Pi over 2 and 1. So that's the point on the graph of sine. So which point will lie on the graph of sine inverse? 1 comma pi over 2. What's the position of that? The position of that is, you agree that this point here would be 1 comma pi over 2, right? You agree? I have the point pi over 2 comma 1 on the graph of sine, so 1 comma pi over 2 will be on the graph of sine inverse. And so that's the one that I highlighted. Will the point 0, 0 be on the sine inverse? Because sine takes 0 to 0. Sine inverse will take 0 to 0 as well. So I get this point here. And also, I have a point which is negative pi over 2 comma 1, right? Comma negative 1. That's a point on the graph of sine. So on the graph of sine inverse, I am going to get a point which is this point here, right? Sorry, which is this point here in pink. You agree? That's the point negative 1 comma negative pi. So this is the point. Let me actually delete what I wrote here and highlight the fact that this is the point negative 1 comma negative pi over 2. What's the domain of the inverse function here? Negative 1 to 1, right? So I have the interval from negative 1 to 1, and the graph must be over that interval, right? Okay, so now if I look at the graph of sine function between negative pi over 2 and 0, what would be the reflection of that? Well, the reflection of that would be something like this. Let's see if you agree with that. Right? Again, my skills are a little bit bad. That's why it's not quite showing that they are exact reflections, right? But you get the idea. And then what would be the reflection of the part from 0 to pi over 2? Well, that will be like this. You agree? So the pink one is the graph of sine inverse of x. Is everybody okay with that? Is it clear? Is everybody clear how I got the graph? I mean, if you want, you can plot more points before you draw the graph. Okay, but I think once you draw 3 points on sine inverse, it's easy to understand how the reflection works. Okay, so that's the graph of the sine inverse. Any questions, anybody? Well, now let me again tell you what we did. We have taken the graph of sine function. So we are consider y equals to sine of x, where x is between negative pi over 2 and positive pi over 2. And then so this is 1 to 1. This is 1 to 1, and so has an inverse we denote by either arcsine, okay, arcsine, or sine to the negative 1 x, arcsine x. The reason people write arcsine, because sine to the negative 1, that notation is a little bit confusing, because you see that negative exponent, you think about reciprocals, right? But it doesn't mean reciprocal, right? Sine inverse just means the inverse of the sine function. That's the pink curve. And so what are we saying then? We are saying that if I am looking at sine inverse evaluated at x, what does it mean? It means that it is equal to y if and only if sine of y is x, right? If and only if sine of y is x. What's the, in other words, if I have, let's say, x, and here I have y, and I have that sine inverse is going to take x to y, if I have that sine takes y to x, right? That's the meaning of the inverse. What's the domain of the sine inverse? The domain of sine inverse function is basically negative 1 to 1, which is the range of sine, right? And what's the range? Very good. A range of sine inverse is from negative pi over 2 to positive pi over 2. Are we clear? Now, remember the cancellation properties of inverses. When you have two functions that are inverses, then their composition in any order is always the identity function, right? So what do I mean by that again? It means that if I take sine of sine inverse of x, that's equals to x for all x where? Between negative 1 and 1, because that's the domain of sine inverse. I am applying the inverse first to x, right? And then if I take the composition in the opposite order, if I take sine inverse of sine x, then I get that this is equal to x as well. But this time, what's the meaning of x? The meaning of x is that it's in the domain of sine. Which domain of sine we picked? Negative pi over 2 to positive pi over 2. Okay, so these are the cancellation properties. Whenever you have two functions that are inverses, there is a pair of cancellation equations, right? Like this. Is everybody clear on this? Okay. Let's do some exercises now. Let's think about the following. Okay, let me give an example here. What is sine inverse of root 2 over 2? Can anyone tell me what that is? What is sine inverse of root 2 over 2? So basically, I am looking for an angle where? I am looking for an angle between negative pi over 2 to positive pi over 2, where sine value is root 2 over 2, right? So if I am trying to find sine inverse of root 2 over 2, I am looking for an angle between negative pi over 2 to positive pi over 2, where the sine value is root 2 over 2. Can you give me an angle like that? Yeah. 45, which is pi over 4, right? Which would be pi over 4. Why? Since sine of pi over 4 is exactly root 2 over 2. Between negative pi over 2 to positive pi over 2, this is the only angle where sine takes on the value root 2 over 2, okay? Everybody is fine with that? Okay. How about sine inverse of half? What is that? For which angle do you get sine equal to half? Pi over 6, 30 degrees, pi over 6. Right? And what is sine inverse of root 3 over 2? Root 3, pi over what? What did you say? 3? Yeah, pi over 3. Is that okay? Alright, so let's look at another example. Let me do another example here. Let's say I want to find, so question is find the tangent function evaluated at sine inverse of 1/3. Technically speaking, I should be writing parenthesis around 1/3, right? I should be writing parenthesis around the 1/3 because what I mean is the inverse sine function evaluated at 1/3, right? Right? Okay, how do I find? So sine inverse of 1/3 is some angle. Where does the angle lie? In the first quadrant or the fourth quadrant, right? The angle is between negative pi over 2 to positive pi over 2. And now I am applying tangent to that, right? So I want to know what's the tangent. I don't want to know exactly what's the value of the angle. I don't want to know exact value of sine inverse of 1/3. What I want to know is what's the value of tangent at that angle, whatever that angle is. Are we clear? Alright, so how would I do this? Well, we just go back to the definition of sine function, which is a wonderful definition, right? Let's see. Let me make my favorite circle first. Good enough. Okay, so I know that the angle, so here what I'm going to do is I am going to denote by theta sine inverse of 1/3. So I know the sine inverse of 1/3, whatever that is, it's an angle, and I'm denoting that by theta. Can someone tell me, for the angle theta, what's the position of the terminal side? If you look at the angle theta, it has a terminal side, right? What's the position of the terminal side? Is it in the first quadrant? Is it in the fourth quadrant? Do I know that? It's in the first? Very good. Why? Because 1/3 is positive, right? Remember, sine inverse of 1/3 is an angle for which is an angle between negative pi over 2 to positive pi over 2, for which the sine value is 1/3. In the fourth quadrant, sine values are always negative. So the sine inverse angle, it has to be in the first quadrant. Okay? So I know that the angle theta is here. Okay, that's the terminal side of the angle theta. Well, let me complete this reference triangle. Remember this reference triangle for theta. And I have coordinates here. So theta is sine inverse of 1/3. That simply means what? Sine of theta is 1/3, right? Now, sine of theta is also what? The definition of sine theta is opposite over, not adjacent, opposite over the hypotenuse. So, can I say that the opposite here has length 1? The opposite of the reference triangle, I'm going to take the opposite length to be 1, and then I'm going to take the length of the hypotenuse to be 3. Am I making sense? Alright. 3 means what's the radius of the circle? Radius of the circle is equal to the hypotenuse, right? It's 3. The radius of the circle is 3. Now, can someone tell me what's the length of the adjacent now? If engineers don't know that, they better leave engineering, right? It's the Pythagoras Theorem, right? It is in all over engineering, right? Am I right? All right. So what is the other side? Yeah. So you take the square of the hypotenuse minus the square of the opposite, and then what is that? 9 minus 1, which is 8. You take the square root of that, which is root of 8. What are we using? Pythagoras Theorem, right? All right. So once I have this, remember, I am trying to find tangent of sine inverse of 1/3, which means I'm trying to find tangent of theta, right? Now, what is tangent of theta? Opposite over adjacent for the reference triangle. And then what is that? Opposite is 1, adjacent is root of 8. Well, if you want to be a little bit more fancy, you can write it root 8 as 2 times root of 2. Is everybody okay? Did that make sense? Now, what we did in this example is very, very important for us. Why? Because you're going to have to do this sort of stuff again and again and again for the next few sections, okay? Am I making sense? If you're not comfortable with trigonometry, please go and review trigonometry. Watch the videos I made in Calc 1, okay, on trigonometry. Watch them over and over again. I don't care how much time you have to spend. You better get used to trigonometry, right? Okay. And don't tell me trigonometry is not important for engineering, okay? Because if you say that, well, you just don't know then what's engineering all about. Okay, so here's another example. Let's look at a new function. I'm going to call that f of x, and I'm going to take that function to be the inverse sine function evaluated at 2x plus 1. Okay, and 2x plus 1. And the question is, what's the domain of f? This sort of problems that I am going over here is basically these sort of problems are trying to see if you understand what's the domain of the sine inverse and how does it relate to the domain of this function, right? Yeah, go ahead. What do I need? Sine inverse, if I say sine inverse of certain quantity, right? That quantity has to be where? I can apply sine inverse function to what numbers? Remember the domain of sine was from negative pi over 2 to positive pi over 2, but the domain of sine inverse, negative 1 to 1. So I can apply the sine inverse only to numbers between negative 1 and 1. So whatever 2x plus 1 is, it's got to be where? 2x plus 1 better be between negative 1 and positive 1, including negative 1 and positive 1. Otherwise, I cannot apply sine inverse. Well, what does it mean for x? Well, it means 2x is between, I have to subtract 1, right? It'll be 0 here, it will be negative 2 here, and then if I divide by 2, I get negative 1, x less than or equal to 0. And that's the domain of f, which is negative 1 to 0. Is everybody okay? Okay. So you agree that 2x plus 1 is between negative 1 and 1? Okay, now I am subtracting 1 from each side, right? So if I subtract 1 from the leftmost side, I get negative 1, which is negative 2. If I subtract 1 from the middle term, I get 2x. And if I subtract 1 from the right side, the rightmost side, I get 0. And then you divide by 2. Because 2 is a positive number, when you divide by 2, you don't have to reverse the inequality, right? So you end up with negative 1 to 0. Is everybody okay with that? Okay. Let's look at a similar example. This time I want to look at, let's say the function g of x is the function sine inverse of x squared minus 1. And again, the same question, what's the domain of this function, right? What's the domain of this function? Alright, so how would you answer that? What's the domain of sine inverse? Okay, so we start with the fact that x squared minus 1 has to be between 1 and negative 1. And now we need to solve for x, right? So we need to isolate x. What should I do? Add 1, so I get x squared less than or equal to, if I add 1, I get a 2. If I add 1, I get a 0, right? So I get x squared is between 0. X squared is between 0 and 2, right? Is everybody okay with that? So what can I say? If I want x squared to be between 0 and 2, what can I say about x? What's that? Just between 0 and radical 2. So here's the number line. And let's say here I have negative root 2. Here I have 0, and here I have positive root 2, right? How about the numbers here? If I take a number there, what's the square of that? Is it still less than 2? I mean, is it still less than 2? For example, the number negative 1 is there, right? Root 2 is a little bit above 1, right? So if I take the negative 1, what's the square of negative 1? Still less than 2, right? So in fact, the domain is everything between negative root 2 to positive root 2. So the domain of G would be everything between negative root 2 to positive root 2. Another way of seeing this, okay, so if I look at this, and x squared is between 0 and 2, can't I say, well, let's look at x squared is less than or equal to 2 and try to solve that. If x squared is less than or equal to 2, then what is, if I take the square root on both sides, what do I get on the left side? What's the square root of x squared? Not just x, absolute value of x. What is the square root of 2? Well, it's just root 2. I'm not saying plus or minus, right? I am taking the positive root of both sides. If I take the positive root of both sides, that's what I get. But absolute value of x is less than root 2 means what? Well, it means that x is between negative root 2 and positive root 2, right? You agree? Everybody's okay? Any questions? You realize that the domain has to be between negative root 2 and positive root 2, not just from 0 to root 2. Okay, because if you take the negative, the numbers between 0 and negative root 2, you square, then you still get something positive less than root 2, right? Less than 2. You still get something less than 2. Are we clear on this? Okay. Well, now of course we have a new function, and as soon as we have a new function, what do? We want to know the rate of that function, right? What's the rate of this function? What's the derivative? What's the derivative of the inverse of x? Well, you can either use the formula that I gave you to find the derivative of the inverse, or you could do the following. You could take y and set it to sine inverse of x, and then apply sine on both sides. So take sine of y. And what is sine of sine inverse of x? So I get what? Sine of y is equal to x. Now what will I do? Well, I'm going to take the derivative of both sides with respect to x. Take the derivative of both sides with respect to x. And let me tell you what's the derivative of the harder side. The derivative of the harder side is just 1. Okay, so what's the derivative of the left hand side? Very good. So derivative of sine y is cosine y with respect to y, but then you have to multiply by dy dx, and I'm going to use y prime for that if you don't mind. Okay, so what is y prime then? 1 over cosine y. Do you like fractions? Probably you don't. Otherwise you're not going to be normal. Okay, so what is 1 over cosine? Secant. Okay. Well, actually, yeah, it really didn't matter, but I'm going to write secant y. So okay, so y prime is equal to secant of y. Am I done yet? I want to write see, I'm taking the derivative of sine inverse of x, right? So y is sine inverse of x, and I rather want my answer in terms of what? X. So what should I do? What's that? Yes, so you're talking about going back to the circle, right? Why going back to the circle? Because I want to express the derivative in terms of x, and let's see how we could do that. Remember, we took y to be sine inverse of x. So what does it mean? It means that sine of y is equal to x. Do I know the position of y? Well, in this case, it depends on x, right? If x is positive, the angle y will be in the first quadrant. If x is negative, the angle y would be in the fourth quadrant, right? Am I making sense? Y is sine inverse of x. So we know that x is between negative 1 and 1, right? When x is between 0 and 1, right? Y is in the first quadrant. When x is between 0 and -1, y would be in the fourth quadrant. Am I making sense? Remember, sine inverse is giving you an angle between -π/2 and +π/2. So I'm going to assume for a second that y is in the first quadrant, or y is a positive angle. So if y is a positive angle, then y would be right here. If y is there, then the fact that sine of y is x, sine of y is x, but I know that sine is also opposite over the hypotenuse. Now I'm going to think of x as x divided by 1. So I can take the length of the opposite to be x, and I can take the length of the hypotenuse to be 1. What would be the length of the other side? What? Square root of the square of the hypotenuse minus the square of the opposite. What's the square of the opposite? 1 minus x squared, right? Remember, the opposite is x, right? This is the opposite. And so, from there, can you tell me what is secant of y? Secant of y would be, secant means opposite of cosine, which means it's adjacent, it will be hypotenuse over. So it is the hypotenuse over the adjacent, because it's the opposite of cosine. And that's exactly, in our picture, it is 1 over root of 1 minus x squared. Now you might say, hey, what if y is in the fourth quadrant? So what if y is negative? What if x is negative and y is negative because of that? Well, my picture will be on the other side of the x-axis, but the same thing happens. Nothing changes. Am I making sense? So instead of y being in the first quadrant, notice that if I have that y is in the other quadrant, nothing will change. I still get the same result. So let's take y to be in this quadrant. So I get y here, and then look at this side. All that means is that x is negative, but it doesn't matter. The opposite is right now is this side. The hypotenuse is still 1. The adjacent is still 1 minus x square root of 1 minus x squared. So still, secant of y is going to be 1 over square root of 1 minus x squared. Am I making sense? Okay, you have to really understand the definition of sine and cosine very, very well, okay, in order to do well on this type of questions. Now, at the end, what formula did I get? What's the derivative of sine inverse of x? It is 1 over the root of 1 minus x squared. Of course, here, keep in mind that the domain of sine inverse is what? -1 to 1. Okay, and of course, when you look at the derivative, I should exclude the equalities here because those are the end points of the graph. So the derivative is between -1 and 1. Any questions on what we have done? Now, as soon as you have a derivative formula, you have an antiderivative formula, right? So what's the antiderivative of 1 over the root of 1 minus x squared? So remember, so far we were afraid of taking integrals of root functions like this. Okay? But now I can say the integral of 1 over square root of 1 minus x squared dx is the inverse sine function. Okay? The inverse sine function is that. Are we okay with what we did so far? Boy, it takes the entire class, huh? Okay, so here's another example. What's the derivative with respect to x of sine inverse of 2x squared minus 1? What is that derivative? Well, if 2x squared minus 1 were just x, then the derivative would be what? 1 over square root of 1 minus x squared. X would be 2x squared minus 1 square of that. You realize that? If 2x squared minus 1 were just x, then this is the derivative. You take 1 over root of 1 minus x squared. However, 2x squared minus 1 is not just x. You multiply by the derivative of that, which is 4x. Again, you are using chain rule, right? Are we okay with that? Very quickly, another example. What's the integral of 1 over 4 minus x squared root of that dx? How would you find that integral? How would you find that integral? Well, notice that it looks so much similar to 1 over root of 1 minus x squared, right? Instead of 4, if I had 1 minus x squared, then I would have said that the integral is what? Sine inverse, right? So, psychologically then, I would be thinking, hey, how do I make that 4 1? Right? So, in order to make that 4 1, the trick is the following. You want to replace x by 2 times another variable. So, you're going to do a substitution which is going to look like this. Which is going to be x is 2 times u. In other words, what is u? U is half of x, right? Am I making sense? That's the substitution you're doing, but what is the meaning of that in terms of du? So du, not du, sorry. What is dx then? Dx is 2 times du, right? And I'm going to make that substitution here. 1 over 4 minus 2 times u. Remember, 2 times u is this is x, and then dx is 2 times du. Once I make that substitution, that simplify. What I have here is 1 over 4 minus 4 u squared 2 du. And now you can see that you can take that 4 out. 4 times 1 minus u squared root of that 2 du. This is equal to the root of 1 over 2 times the root of 1 minus u squared 2 du. 2 cancels out. 2 cancels out. I get the integral of 1 over root of 1 minus u squared. There you go. I made it look like 1. I made 4 look like 1. And then what do I get? I get that this is sine inverse of u, but u is x over 2. And that's it. Okay, I'm going to end here. I think I'll right on time. Okay. I still want to do 2 more examples on sine inverse before I move on to something else.